3.5c. This is going to be kind of fun. Find the dimensions of an open rectangular box of maximum volume that can be made from a sheet of cardboard 8 inches by 11 inches by cutting congruent squares from the corners and folding up the sides. Find the volume. Okay, let's draw a picture of what this means. First, we're starting off with a piece of cardboard 8 by 11 inches. So that's pretty much the same size as a piece of paper. So let's just pretend we have like a cardboard that's in the same size as a piece of paper. Okay. Find the dimensions of an open rectangular box of maximum volume that can be made from a sheet of cardboard 8 inches by 11 inches. So this is 8 inches. This is 11 inches. By cutting congruent squares from the corner. Okay, so let's say we make a cut of this square, and they all have to be the same. They all have to be squares. All right, so if we cut the squares, notice what will happen. We can fold them up, like this piece is going to fold up, this will fold up, this will fold up, and this will fold up at those corners by cutting them out. So just imagine these being gone right here because we just cut them out. Okay, and now we can fold this and fold this, and it'll look something like this. I'm going to go down here, down here. Okay. Just something like this. I'm not an artist. My dad was, but I'm not an artist. I'm sure some of you are. Could do a better job, huh? Okay. So we folded up the box, and there we have an open box. Okay. Now we have to find what we can get the maximum volume. We know volume equals length times width times height. Okay. Well, what is our length? What is our width? What is our height? We have to figure that out. We know that this, we don't know how much we cut in to make the square. So we're going to call this x. But since it's a square, this will be x length. In fact, all of these will be x length. Okay, x length. Now, in order to get this piece right here, originally it was 11 inches. And what did we do? We cut out x here and we cut out x here. So this length right here is going to be 11 minus 2x. That's going to be the length of this box. 11 minus 2x. Once again, this originally was 11 inches, but we cut off this x and we cut off this x. So we took away 2x. Now this is 8 inches all the way across, right? But we cut off this x and cut off this x. So this is going to be 8 minus 2x. Okay. So we have the length, we have the width. Do we have the height? Well, yes, we do. This is x. Our height is x height because that's what we cut off and we folded it up. So it's x height. So let's go ahead and write our equation now. Volume equals length, which is 11 minus 2x, times width, which is 8 minus 2x, times height, which is x. Okay, so I'm going to call this v of x. We're going to go ahead and, after we multiply this with this, we'll FOIL. Then we distribute our x, and our end result will be 4x cubed minus 38x squared plus 88x. Okay. To find the maximum volume, we're going to go ahead and take the derivative of the volume, and we get 12x squared minus 76x plus 88. Now we set that to 0. All right, is this factorable? Well, it might be But we're not going to take our chance and waste our time. Let's just use the quadratic formula. So we're going to say A equals 12, B equals negative 76, and C equals 88. Actually, I'm going to do something else. I notice they all have something in common. I'm going to make it easier on myself to calculate. What do they all have in common? They all have a 4. So let's divide everything by 4.